I'm Anil Kumar. Welcome to my series on calculus. We will see how to find derivatives using first principle or by basic definition. The question here is, use definition of derivatives to find the equation of a line that is tangent to the graph of f of x equals to square root of x plus 1 and perpendicular to 6x plus y equals to 3. Now in this particular case, we'll actually find derivative of the function using the basic definition of rate of change with limits, which is f dash x. The derivative of the function is limit h approaches 0 for f of a plus h minus f of a over h. Okay. So with this, we really don't know at which point will the tangent be perpendicular to the given line. So we'll have to find derivative of the function f dash x at any general point x. Correct? So I should have used not a here, but I should have used x here. So let me just make a correction here. We'll use f of x. So on purpose this was done so that you understand when to use f of a and when to use f of x. In this situation, we do not know the point at which we need to find the derivative, and therefore we are going to use this definition of derivative of the function as limit h approaches 0 for f of x plus h minus f of x over h. Is that clear to you? So the very first step is very important here to understand. Now what are we looking for? We are looking for this derivative, the slope of the tangent line, to be same as perpendicular to this line. Line given to us is 6x plus y equals to 3. So 6x plus y equals to 3 can be written as y equals to minus 6x plus 3. Now slope of this line is basically equal to minus 6. We are looking for perpendicular. So line perpendicular will have a slope of 1 over 6, negative reciprocal, correct? So we want this derivative to be 1 over 6, since we want it to be perpendicular to this line. Perfect. Therefore, we can write that this particular derivative, whatever you calculate, should be equal to 1 over 6. Right? Now we are given the function f of x as square root of x plus 1. So we can replace this here and then find the derivative. But we know that the derivative should be 1 over 6. Is that clear to you? So I'm writing 1 over 6 for the derivative at a particular point, and we don't know what that point is. So x we'll find later. We get here limit h approaches 0 for this function. So f of x plus h means replace x with x plus h. So we get square root of x plus h plus 1 minus the same function, which is square root of x plus 1 over h. We should rationalize the right hand side. So what we get here is 1 over 6 equals to limit h approaches 0 and here we get square root of x plus h plus 1 minus square root of x plus 1 over h. To rationalize means to multiply and divide by the conjugate of the numerator, which is square root of x plus 1 plus square root of x plus 1 divided by the same thing. Correct? Now, so that gives us limit h approaches 0. Now, when you multiply them, you get difference of squares. So we get x plus h plus 1 minus x plus 1 over all this, which is h times, let me put it in a bracket, square root of x plus h plus 1 plus square root of x plus 1. Now when you open the numerator, what do you get? You get this as limit h approaches 0, x and x cancel, plus 1 cancel, you're left with h, right? So h over all this, square root of x plus h plus 1 plus square root of x plus 1. Clear? Now we'll take it to the right side and solve it further. So from here we can cancel h and h from numerator and denominator. So what we get here is that 1 over 6 is equal to, substituting h as 0, we get 1 over, here we get square root x plus 1, here also we get square root x plus 1, correct? So 1 over 6 is equals to 1 over 2 times square root of x plus 1, correct? Now we can cross multiply and we get square root of x plus 1 equals to 3, right? So this cancels, you get 3. Squaring, we get square root of x plus 1 whole square equals to 3 square, which is 9, right? So we get x plus 1 equals to 9, or x is equal to 9 minus 1, which is 8. So we get a value of x as 8. So at x equals to 8, the slope of the tangent line on this particular curve will be 1 over 6, which is perpendicular to the given line. Is that clear to you? Correct? So we got the x value. We should also find the y value. So y will be what? That is f of 8 is what? So f of 8 will be, substitute 8 here. So square root of 8 plus 1, which is 3. So we get our point, right? So at a point which is x value of 8, the y value is 3, we have a slope which is 1 over 6. Perfect. So that's what we get. So now let's find the equation of tangent line. So we have done the first part. We have actually found the coordinates of a point, and we also know the slope at that point, right? So basically what we've done here is, let me just sketch it here, that we have a graph which is square root of x plus 1, kind of like this, and we found that at a point 8 the slope is 1 over 6. So somewhere here, let's say this point is 8 and the y value here is 3, right? At this point slope is 1 over 6. Is that clear to you? And this slope is perpendicular to the given line, right? Now we need to find the equation. So we can write the equation in the form of y minus y1 equals to m times x minus x1. So we have y minus y value of 3 equals to slope 1 over 6, x minus x value of 8. Cross multiply, 6y minus 18 equals to x minus 8. Bring the terms together, so we get x minus 6y, and that gives us, we'll write it 2 steps, plus 18 equals to 0, or we can say x minus 6y plus 10 equals to 0. So this becomes the equation of the tangent line. You get the idea. So equation of this line is x minus 6y plus 10 equals to 0. So I hope the concepts are absolutely clear. So in situations where you don't know at which point we have to find the derivative, we have to start with general expression and find derivative of the function f dash x. Perfect. And then solve it as shown here. So I hope that this is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.